Tonight's objective is I can solve equations involving the distributive property with variables on both sides of the equal sign. This first slide just reminds you of what we went over in class. Keep in mind the steps. You first distribute, then you combine like terms on each side, move all variables to the left, move all constants to the right, and then divide both sides by whatever that coefficient of x was to isolate the x by itself on one side. If you need to pause the video, try running through this example, you can do that. But what I'd like to focus on tonight is just going through the 3 homework problems you had. You should have tried these problems, so I'm going to try running through it fairly quickly with you. First of all, I just want to tell you, which we talked about in class, if there's no coefficient in front of a set of parentheses, you can assume that it is a 1. So here, I keep my minus 5x minus 18 equals 2, and then I distribute. Negative 1 times x is negative 1x. Negative 1 times negative 4 is a positive 4. Then I keep my plus 2x, which was outside the set of parentheses. On the left-hand side, there are no like terms to combine, so I just leave that. On the right-hand side, I have minus 1x plus 2x. Well, 2x minus 1x is 1x. Then I have 2 plus 4. 2 plus 4 is 6. Now I want to move all of my variables from the right to the left. How do I move this 1x? Well, I need to zero it out. 1x minus 1x will zero out. If I'm going to subtract 1x on the right, I need to subtract 1x on the left-hand side of that equal sign so that the equality can remain. Minus 5x minus 1 more x is minus 6x. Still minus 18 equals, I'm only left with a 6 on this side. Now I'm going to move all of my constants over to the right. Well, how do I zero out a minus 18? Oh, I need to add 18 to zero that out. If I'm adding 18 to the left, I need to add 18 to the right-hand side of that equal sign. On the left-hand side, now all I'm left with is minus 6x equals 6 plus 18 is 24. What's the operation between that negative 6 and the x? It's multiplication. I undo that multiplication using division. And I'll always want to divide both sides by the coefficient of x to get x by itself. So if I'm dividing by negative 6 on the left, I'm dividing by negative 6 on the right. Negative divided by a negative is a positive. 6 divided by 6 is a fancy form of 1. 1 times x is x. And that tells me I have isolated x all by itself. 24 divided by a negative 6, positive divided by a negative is a negative. 24 divided by 6 is 4. So there's one solution to this equation, and that solution is a negative 4. What that means is if I substitute, that should be a negative 5 in front. Let me just erase that. That means that if I substitute negative 4 in place of each x in my original equation, I should come up with a true statement. The reason a check is important is because if I substitute negative 4 in place of each x in the original equation and I don't come up with a true statement, that means I've made some sort of a mistake and need to go back and check my work. So what you do when you're checking an equation, checking that negative 4 truly is the solution, you just simplify the left side of that equal sign. Using your order of operations, simplify the right-hand side of that equal sign after negative 4 has been substituted in and verify you have a true statement. Negative 5 times negative 4 is a positive 20. 20 minus 18 is 2. So the left-hand side simplifies down to 2. Let's see what happens on the right-hand side of this equal sign. Starting in parentheses, negative 4 minus 4, that's a negative 8 within parentheses. So we have 2 minus, and then a negative 8 plus 2 times negative 4. So that's 2 minus a negative 8 plus 2 times negative 4 is negative 8. Still have the 2 on the left-hand side. 2 minus a negative 8 means 2 plus a positive 8. 2 plus 8 is 10. 10 plus negative 8. 10 plus negative 8. Signs are different. Find the difference. Keep what you have more of. Yay, 2 equals 2. This is a true statement. Therefore, x is negative 4 is the correct solution. Let's try the next one. Again, we'll start by distributing. We'll distribute 1/3 through this set of parentheses. We'll distribute a 6 through this set of parentheses. 1/3 times 18 is 6, plus 1/3 times 9 is 3. So that's 6 plus 3q minus q equals 6 times 2 is 12. So that's 12q minus 6 times 4 is 24. Now we try to combine like terms on each side. As I look on the left, I see I can combine the q's. If I don't have a coefficient, I can always write in a 1. So that's 3q minus 1q. I choose to write that as 2q. 3q minus 1q is 2q. This is a positive 6, so we're still just going to be adding 6 equals 12q minus 24. I now need to move this 12q to the left. I'm trying to get all of my variables from the right to move over to the left. How do I zero out 12q? Oh, I subtract 12q on the right. So if I'm going to subtract 12q on the right, I subtract 12q on the left. The whole purpose is to zero this out. 12q minus 12q zeroes out. Here, 2q minus 12q is negative 10q, still plus 6, equals. On the right-hand side, I'm left with my minus 24. I then take a look and I say, okay, now I have to move all constants over to the right. So I have to move this positive 6 over to the right. How do I zero that out? Oh, I subtract 6 from there. If I'm going to subtract 6 from 6, that'll zero down on the left. If I'm subtracting 6 on the left side of the equal sign, I'll also be subtracting 6 on the right-hand side. So then I have negative 10q equals negative 24 minus 6 is a negative 30. Make sure you're using your calculator if you need support. Then you always say, what's the coefficient on my variable? Oh, the coefficient on q is negative 10. It's negative 10 times q. How do I undo that? I divide both sides by negative 10. Negative divided by a negative, 10 divided by 10 is a fancy form of 1. 1 times q is just q, and that was the whole point, to get q isolated by itself on the left. On the right-hand side, negative divided by a negative is a positive. 30 divided by 10 is 3. So there's one solution. Q is 3 is the solution. Now I'm going to go ahead and I'm going to I'm not going to distribute. Now I'm going to check. Now I need to check that 3 really works. When I substitute 3 in place of each Q, I really come up with a true statement. So I'm just going to do 1/3 times, in parentheses, 18 plus 9 times in place of Q. I place a 3. Minus, in place of q, we'll put the solution of 3 equals 6 within parentheses 2 times, in place of q, I'll substitute a 3 minus 4. Now I'll just simplify each side of the check using my order of operations and hope that both sides end up the same. If not, I've made a mistake. So now this is 1/3 within parentheses 8 plus 9 times 3 is 27 minus 3. I don't know why I wrote an equal sign right there. There's really no need to have that equal sign there. I'm going to keep simplifying. 18 and 24 is 45. So this is 1/3 times 45 minus 3. 1/3 times 45. 1/3 of 45 is 15. Minus 3 is 12. And I hope once I simplify the right-hand side, I'll also come up with 12. So let's take a look. This is 6, and then within parentheses, 2 times 3 is 6 minus 4. 6 times, within parentheses, 6 minus 4 is 2. 6 times 2 is 12. Oh, yay! This is a true statement, which says Q is 3. 3 is the correct solution. Last one for homework. Again, I'm going to start by distributing. Please make sure you're using your calculators for support, and hopefully you've already tried this problem, and now you're just checking it against me. 0.4 times 2 is 0.8x, plus 0.4 times 1/2 is 0.2, equals 3 times 0.2 is 0.6x, plus 3 times negative 2 is negative 6, and we still have this minus 4 running outside that set of brackets. On the left-hand side, there's nothing I can combine, so now I look on the right. Are there any like terms? Oh, there sure are. Negative 6 minus 4. So on the left, it's 0.8x plus 0.2. On the right, we still have our 0.6x. I can either write this as plus a negative 10 or just minus 10, and that's how I choose to write it. At this point, I need to move all of my x's over to the left. So how do I zero out 0.6x on the right? Oh, I'm going to subtract 0.6x. I look, that had been a positive 0.6x. You look at the sign in front. So to 0.6x minus 0.6x, zeroes out. If I zero out that my bad. If I zero out that 0.6x on the right, I need to also subtract 0.6x on the left. You have to always make sure you are keeping that equality. So whatever you do to the right-hand side of the equal sign, you also do to the left. 0.8x minus 0.6x is 0.2x plus 0.2 equals, only thing I'm left with here is a negative 10. At this point, I need to move this constant of 0.2 over to the right. How do I zero that out? Plus 0.2, inverse would be minus 0.2 to zero that out. If I'm going to subtract 0.2 on the left, I need to subtract 0.2 on the right. 0.2 minus 0.2 zeroes out, so the only thing I'm left with on the left is 0.2x equals negative 10 minus 0.2 is negative 10.2. I'm going to divide each side by whatever the coefficient on x is. So I'm going to divide each side by 0.2, because whatever I do to the left, I must also do to the right. The whole point was to isolate x by itself. 0.2 divided by 0.2 is a fancy form of 1. 1 times x is just x. Negative 10.2 divided by 0.2 is negative 51. Use your calculator to support you if you need. 0.2 I know is the same as 1/5. So I did negative 10.2 divided by 1/5. That's negative 10.2 times 5. And when I multiplied those together, I came up with my negative 51. But use your calculator for support. But anytime you're dividing by something between 0 and 1, you're actually going to end up with a larger number. Now to check that negative 51 is the correct solution, I'm just going to substitute in. So oops, that's not a negative, that's a 0.4. Sorry about that. So I'm just going to do 0.4. And then in parentheses, 2 times negative 51 plus 1/2. On the right-hand side, 3 within parentheses, 0.2 times negative 51 plus negative 2 in parentheses, and then minus 4 on the outside. Oops, I'm going to keep that bracket. The parentheses around the negative 2 doesn't really affect us. So this is 0.4 times 2 times negative 51 is negative 102 plus 1/2 equals, I'm going to just keep simplifying, 0.4 times negative 102 plus 1/2 is negative 101.5. And 0.4 times negative 101.5, I believe, is negative 40.5, if I'm correct. And on this side, I have 3, and then within parentheses, 0.2 times 51 would be negative 10.2 plus negative 2, keeping my brackets, minus 4 on the outside. That's 3, and then in parentheses, I have negative 10.2 plus negative 2 is negative 12.2. Keeping my minus 4 on the outside, negative 3.2 times negative 12.4 is negative 36.5 minus 4 more is negative 40.5. And that's a true statement, so we know we're good to go. So hopefully that worked out and that made sense, and that helped support you on tonight's homework. Try to have a good night. See you tomorrow.